Thank you. Hi, everyone. My name is Nabil Ali-Mohamad, and I'm a research assistant at Michael Smith Laboratories at UBC, supervised by Dr. Christian Kastrup, and I'm set to start my first year of medical school this fall. I'm happy to be here with you to present one of our hemostatic materials projects titled Extra-terrestrial soils. Next slide. Now, we may not be on Earth forever. While we have already sent 12 people to the moon so far, and over 550 people have reached the altitude of space, we are far from finished exploring the great beyond. Just this past September, NASA unveiled the Artemis space program plans, which brings humans back to the moon for a long-term stay as a trial for building a base on Mars. And these bases are expected to be built in the next 2 decades. So naturally, as our lab explores materials for hemostasis, we asked, can extraterrestrial soils trigger the coagulation cascade? We asked this knowing that both the moon and Mars have about 40 to 45% silicate concentration on the surface, which I will touch on again in a moment. Next slide. So here on Earth, we have our usual hemorrhage statistics, where 5 million deaths per year are due to trauma, and 40% of these deaths are due to hemorrhage. But the question is, what about extraterrestrial trauma? While people living on the moon and Mars won't be getting into motorcycle accidents anytime soon, and space war is quite difficult to imagine at this point, though we probably shouldn't count it out based on what Colonel Andre Kapp said earlier today. It is still very likely that hemostatic materials will be required for those living away from Earth. So in this project, we seek to explore whether extraterrestrial materials could be used to manage lethal hemorrhage. This goal falls in line with how NASA has placed a major emphasis in situ resource utilization, as we seek to use raw materials from these foreign planetary bodies for medical purposes. Next slide. Last year, our lab published this paper titled Coagulation Factor 12 Contributes to Hemostasis when Activated by Soil and Wounds. What we saw in this study was that it appeared that as the surface concentration of silicone increased, the time it took for a clot to form decreased as measured by a standard clotting assay. Further, we saw that soil B, which was a soil sample taken from the lower mainland, which we found to have high silicate concentrations, seemed to reduce blood loss in a factor 12 dependent manner in a mouse tail transection model. Next slide, please. So to test our hypothesis in vitro, we sought the help of collaborators at the Colorado School of Mines who specialize in producing lunar and Martian soil simulants. We tested 2 lunar simulants whose chemistry is near identical to the samples which were returned to Earth during the Apollo missions. And we're also presenting data from Mars global simulant, as well as a true North Africa 869 meteorite. In an in vitro clotting assay, we found a familiar pattern with these ET soils, as we saw with soil B, where our extraterrestrial simulants and meteorite all showed to form clots in a factor 12 dependent manner. Normal control plasma is also seen to clot faster when in the presence of extraterrestrial soil simulants or meteorites, and behaves in a similar manner to kaolin, which is impregnated in combat gauze, a staple in the med packs of soldiers in Canada and the US. Next slide, please. Finally, we tested these soils in a porcine surgical bleeding model, where after a laparotomy, 2 by 1 centimeter incision was made into the left medial lobe of the liver with a scalpel. We promptly poured 2 grams of ET soils into the bleeding wound and gently placed normal gauze on the injury just to keep the powder in place without applying any pressure. We saw that the Martian and lunar simulants tended towards faster clotting times compared to plain gauze alone, with our meteorite sample significantly reducing the time to hemostasis. Additionally, the use of extraterrestrial soils overall showed less blood loss than plain gauze alone. Overall, these are very promising results, which point to how we may choose to use extraterrestrial soils to produce hemostatic agents when we have settled on other planets. This may be hard to imagine for many of us listening right here right now. But when we're talking about interplanetary travel, every gram of payload counts. And seeking alternative materials native to the planet we are exploring will be our best way forward. And with that, I will gladly take any questions.
Thank you very much. That was fascinating.
Yes, can I ask a question, Dana?
Of course.
Yeah, so Nabil, that was very fascinating. Actually, I like all the student talk. You're all excellent. That's very impressive. So that's sometimes I thinking whether U of T able to recruit these talent students, but it looks like people like BC, Vancouver better than this. These days, I also saw the China send something to the Mars as well, because China is heavy populated. People may want to get rid of from there. That I'm not sure. So, but I would ask another way. So whether during the human migration, the way during the evolution, so we think about that human being from 65,000 years ago was migrated from east of Africa, whether in the human migration track, so whether some area is the soil is similar to, as you say, the extra-terrestrial soil. So that is a problem. Human beings want to keep their surviving. So therefore, they develop this factor 12 system. But today, because most of us living within the building, the story changes, right? So
right.
This comment, whether there is evolution force, so that's that could also tell us whether today we less need factor 12, but in the future, during the interplanet traveling, we do need the factor 12 again.
That's right. Yeah, absolutely. Well, thankfully, we haven't evolved away from factor 12, and the vast majority of us still have it within us. And so actually, this is something that NASA's actually thought about, not necessarily factor 12 specifically, but where on these planets, or in the case of the moon, would be the best place to set a base. While we still haven't figured out the exact surface concentrations of all across Mars, since we've only sent, I think there's 3 rovers up there now. With the moon, something that they've said is that we will probably put a base in a highland region instead of a Mar region. And that's because the clay content of the soils there are a lot higher, which might help a lot with building materials and with growing foods and things like that. So I think very much that the focus has been on going to areas with high clay concentrations, high silicate concentrations. So we will hopefully not die from hemorrhage anytime soon.
Great. Okay. Thank you very much. That was very interesting. I'm going to go back and rewatch The Martian tonight.